Greetings and welcome to Chapter 7 about space, Part 2. Linear perspective is a system. It was developed in the early Renaissance, primarily in the 14th century, and it's a means of organizing imagery on a two-dimensional plane in order to suggest three-dimensional space. The following four terms are all components of linear perspective, and they will be explained as we get to them. One-point perspective is the simplest of all the linear perspective models. It involves a single vanishing point located on the horizon. Well, there's the horizon. Oh, we can't see it. It's blocked by buildings. Does that mean that it disappeared? No, it's still there. The vanishing point is right here. And one-point perspective only works when the vantage point, that's where you, the viewer, are located, is directly parallel to all the edges and sides of all the objects that are converging, coming together on this point, like the railroad tracks. These railroad tracks are parallel, but they appear to be coming together or converging as they move towards the horizon. And finally, they basically meet here at the horizon. Notice that these ones do too. And the edge of this building, the roof line, if we trace it along, it meets here too. These ones here are set at angles to all of these other edges. And if we trace their roof lines, they come all the way, on the horizon line outside of the picture. So one-point perspective is dependent upon a very, very specific orientation of the viewer parallel to the planes and edges. Here's our friend Canaletto again, painting a little piazza in Venice, as was his habit. This particular picture is organized in one-point perspective. And if we trace all the parallel features in this painting, we'll find that they all converge on a single vantage point. Now, when I say parallel, I mean, let's say, the edge right here of this balustrade. If it continues down, it comes across here. Where's the horizon line? Oh, we can't see it. It's blocked by the buildings, but it's still there. So memorize the path of this line as it moves across this area. Then also, let's go with this line right here in the pavement. It continues on here, stops, continues again. And look, it crosses kind of similarly with that line right through here. How about, this is a parallel edge. How about right here? This edge is parallel to this one, and the top of the arcade. They all seem to crisscross right around here. That's where the horizon line is. And this is the vanishing point. All of these parallel edges and lines appear to vanish at the horizon here. They converge upon this point. It gives the illusion of the three-dimensional space of the Campo di Rialto. But what happens if we turn at an angle? We can't use one-point perspective anymore. If we turn even at a slight angle, away from parallel to the edges that we're looking at, it doesn't work. So then we need to move to two-point perspective. This requires that we have vanishing points, and they're not established or picked out of the air. They are discovered by, in this case, the architecture. There are two vanishing points on the horizon. Let's find them. We can trace the sidewalk up through here, up through here, up through here. Oh, we're off the picture. Here's the vanishing point because it lines up with this edge, this edge, this edge, this edge, this edge. These are all parallel edges, and they all vanish here, giving the illusion of the recession of space going this direction. On the other side, the same thing is true. The vanishing point is here, off the edge of the picture. It does not have to be inside the picture, but all of these edges traced down all converge on the same place, and that is on the horizon at a vanishing point here, number 1, and a vanishing point here, number 2. This is a famous painting by Gustave Caillebotte, and it is a wonderful example of two-point perspective. In particular, let's look at this building right here. Very similar in concept to the buildings that we looked at in the previous example, where all of these edges, which are on a parallel plane with each other, they all descend to a point right about here, the vanishing point. Same is true on this side over here. They all come down to the same point or the same horizon line, different point right here. For this building, those are the two vanishing points. But this picture has other buildings, and these other buildings are arranged such that the planes of the sides of the building are not parallel to this one. Those buildings have their own sets of vanishing points. Here's this one over here. We can barely see the edges, but this edge would trace down to the horizon right about here or so, right about where the umbrella handle is. And then the same edges would come down like that and trace down to a vanishing point here. We can't see the other sides of the buildings, and so we don't know where those vanishing points are. But the vanishing point that we can see for this one is right there. For this building, right here and right here. Two-point perspective. Three-point perspective is basically the same thing as two-point perspective, except that we've chosen to move our view from a horizontal, flat view to a view that takes into consideration the vertical element, meaning we're looking up or we're looking down. And that's why it's sometimes referred to as worm's eye, looking up, bird's eye view, looking down. This particular example, beautiful painting, bit abstracted with multiple perspectives and whatnot. But notice the edges of the buildings, as they go up, they all appear to converge on a point that is up in the sky. In fact, it's off the edge of the slide. Well, it's a beautiful painting. It's from the book, and I left it in, but it's maybe not the best illustration of three-point perspective. This photo, on the other hand, is an excellent illustration of three-point perspective. Notice how these buildings, and they're not actually leaning in real life, but they appear to cone. They appear to converge and come together at a point that's high up in the sky. Well, here we go. Empire State Building, New York City. This edge traces up, well, way up high, off the picture. And this traces up, but you can see how it's converging, and they will eventually meet. The sides of the Empire State Building and these other buildings are parallel to each other. So this edge right here, it also is raising up high, high, high in the sky, the zenith point above us, where it will converge with this one and this one and this one and this one and this one, etc. That's three-point perspective, the vertical element. Sometimes the artist has to alter or distort the appearance of the subject matter in order to make it look visually correct. Typically, this is foreshortening. Foreshortening is a member of the amplified perspective family of techniques. And this particular example is Caravaggio, the conversion on the way to Damascus, with St. Paul lying down there on the ground. Let's see how it works. In Caravaggio's painting, St. Paul is lying on the ground, his arms outstretched, and his body is angled away from us, away from the viewer. His arms are held up so that they are parallel to the picture plane, which means perpendicular to the direction that we're looking at the picture plane. So we can measure the actual length of his arm, that's the yellow arrow, from the shoulder to the tips of his fingers. When we then take, with the blue line, the exact same measurement, those two lines, yellow and blue, are the same length. And now we measure from the top of Paul's head down his torso, down towards his knee. Well, his knee's pulled up a little teeny bit. But we know that his arm is not as long as the distance from just above his knee to the top of his head. It's shorter than that. but it needs to appear to be that distance in order for us to get the visual correctness of his body extending away from us, receding, appearing to get smaller as it goes into deeper space. This is just an approximation of how vision actually works, and that is foreshortening. This is probably the most famous image by Charles White called Preacher. And we see that his hands and arms are both foreshortened. They are emerging from his body and pointing out at different angles towards us, the viewer. This example is not only a case of foreshortening because of the way the arms are handled, but also consider the size of his hands. Because they are closer to us than the rest of his body, they appear to be about the same size as his face or even his entire head. This is because of relative size. Objects closer to us are larger than objects that are further away as far as how they appear in the image. Amplified perspective. Optical representation is basically the way we see. We're in a particular place, we look, we see whatever we see from that single vantage point. Nice painting by Gauguin. Unlike optical representation, however, artists often employ distortions of three-dimensional space, or at least the appearance of three-dimensional space, in order to accomplish other goals. This is Picasso, a really fantastic, spectacular linocut from 1962, a wonderful year, by the way. And we can easily see how Picasso has distorted the form. First of all, it's a grand abstraction in terms of color and whatnot. It's only three colors, the black and the two pale tans, and he's broken it up into these kind of funny, rectilinear planes. On top of that, though, we look at the face. There are distortions to the eyes, different size, but we see the eyes and the nose and this cheek pretty much square on. As we merge here, all of a sudden, the lips, the mouth, and the chin, they turn at a 90-degree angle to us. That's crazy. Up here, the hat, which would be a curved structure that would roll around this side and around this side, the ornament is displayed flat, laid out flat. So these are several huge distortions of the appearance of three-dimensional space. And well, that's pretty common in modernism. This is a really fantastic still life by Cézanne, and it illustrates what we call flattened space. Flattened space is where the artist is essentially changing the point of view at various different points in the painting. And it has this feature of sort of defeating the realistic illusion of deep space and sort of raising space up and making it seem compressed or flattened. This is how it works. Let's take the picture right here, which looks pretty good through here and up through this ellipse and up through this one and even the front of the opening. But when we get to about here, the ellipse opens up and gets really, really tall and round, as if Cézanne stood up when it was kind of time to paint the opening in the back part here and was looking more down into the picture. The same thing is true for the tabletop, which looks pretty convincing through here, but suddenly it tilts up on this back edge, more so than this one. And it's really obvious here in the plate of cherries. He's virtually on top of the plate of the cherries here. If this were a realistic scene, these cherries couldn't be here. Boom! They'd all slide straight down, crash to the floor, make a big mess. This is space that's been flattened rather than the deeper illusion of three-dimensional space. These two pictures give us a nice comparison between optical representation on the left for Edgar Degas' Café Scene, and on the right, William Johnson's Café Scene is, well, highly flattened space, excellent distortion, and what we call reduced modeling. Over here in the Degas painting, we see linear perspective. These edges, which are parallel to each other, are appearing to recede to a vanishing point, which is off the edge over here, probably right about where this is the horizon line right here. And we see modeling of the forms. Shadow here on her arm, highlight, light across the front. This is basically the same as chiaroscuro, where light falls across rounded surfaces and shadows and highlights give us that illusion of the rounded surface and logical appearance of light modeling on the form. Over here in the Johnson piece, none of that is existing. First of all, he's flattened the space by tilting up the floorboards, distorting the look of the table, flattening out all of their clothing and bodies, squaring them off. So it's very, very flat space. And then it goes so far as to completely eliminate the idea of changing light across various parts of the form. I mean, people are round, right? But there's no change in lighting across her blouse or her face or his face really, or even the rounded aspects of the hats. And he goes so far as to take the texture of the plaid on the man's suit and just arrange it into this kind of simple grid pattern, completely defeating the idea of it being a convincing representation of three-dimensional space. It doesn't make it any less effective. In fact, it makes it into an entirely different piece of art. In the late 1940s, 1950s, all the way up till about 1962 or so, abstract expressionism was king of the art world centered in New York, and Jackson Pollock, the artist here, was considered the high priest of abstract expressionism. Its goal was to produce the ultimate painting, the painting to end all paintings. And that was considered to be a flat painting that acknowledged the picture plane as two-dimensional as opposed to the trickery and sorcery of this falsehood three-dimensional space. Well, Pollock, along with his buddies, were attempting to do this, I guess. And the irony is that, well, they didn't, because when you look closely at a Jackson Pollock piece, you see exactly how it's made. You see how one little drip line and one little splotch, blotch, dot, or whatever it happens to be that he put on the canvas, how it lays over other dashes and drips and dots of paint as well. And so there's depth there. It's shallow depth, but it's depth nonetheless. And that is the fabric of these paintings, the irony. Conceptual representation is where the artist has largely or completely abandoned the conventions of optical representation. Quite often it involves a collage-like composition, many different visual elements that are all juxtaposed together in seemingly an irrational fashion. In this particular example by somebody that you know, it's talking about the St. Francis Dam disaster in 1928, and it includes snippets from photographs in black and white, text, irrational color, inverted images. If you walked outside and saw this, you would be scared. But this type of conceptual representation makes it possible for the artist to express complex, very interesting and difficult concepts that don't fit within the confines of an optical representation type of scheme. Multiple perspectives is a form of conceptual representation. It was developed about 110 years ago, primarily by the Italians, the Futurists, of which the painter of this particular work, Boccioni, was one of the leading members. And the title of the painting sort of tells the story. Simultaneous Visions. It was an effort to exploit in a two-dimensional scheme the idea that the subject matter could be represented from different points of view simultaneously. Well, how do you do that? Typically, the artist had to fracture the imagery and then put the pieces, some of them from each view, back together, which produced this kind of chaotic, wild, irrational, but very dynamic and exciting way of looking at things. If you study this painting carefully, you're going to see roof lines are distorted and twisted, faces appear, faces are distorted. It's really crazy. Ultimately, multiple perspectives expresses a concept that doesn't work very well with a static two-dimensional painting, and that is the suggestion of the fourth dimension, time. Along with it, motion. Here's another extremely famous example of the concept of representing the fourth dimension, time, by Marcel Duchamp, one of the most famous artists of the early 20th century and otherwise interesting guy. So it's his painting Nude Descending a Staircase number 2. And just like the title suggests, it is reflecting the passage of a nude going down a staircase. That involves time. It takes time to move from one place to another. It's funny to think, too, that this painting, when it was first exhibited, was banned, was taken away from view because the 1912 audience considered it just a little too risque. Okay, let's get away from the 2D world a little bit, and I mean a little bit. So here it's relief sculpture, also called bas-relief, also called shallow relief. This is sculpture. It's three-dimensional, but barely. The depth from the objects that are closest to us, the figures right in the center, to the objects that are all the way in the back of the rotunda there, I believe is only about an inch or so. They do cast shadows, but it's necessary to look at this type of sculpture straight on. If you look at it from the side, it becomes heavily distorted and it doesn't read correctly. So when we look at this type of bas-relief, we essentially look at it the same way that we look at a two-dimensional work like a painting. Proper sculpture, of course, is three-dimensional. It has actual volume. It exists in actual space. If we were here, lucky us, to see Verrocchio's David with the head of Goliath lying down there, we could traverse all around the sculpture and look at it from different angles. If we looked at it from the back, we couldn't see it from the front, and vice versa. So sculpture exists in three-dimensional space. Architecture, likewise, exists in three-dimensional space. It encloses actual space. It is functional sculpture. And this is definitely art. This is the nave of Beauvais Cathedral, the tallest of all the Gothic cathedrals in France. It's quite stunning and beautiful, beautifully crafted. But it's just like sculpture, exists in actual space. And finally, here is the Parthenon, perched atop the Acropolis Hill above Athens. This is a pretty beautiful structure. Once again, occupying three-dimensional space as architecture. Maybe seen better days, but nonetheless still interesting as a relic of a different time. And that's it for space.